Hello everyone, and welcome to the guided notes, lesson 5 for the quadratics unit on optimization problems. So these are quadratics that are modeling some sort of situation, and in order to solve these, we need to be able to use or create or use, if given, a quadratic equation. So let's get started. A farmer has 120 feet of fencing with which to enclose 2 adjacent rectangular pens as shown. Assuming that he's going to cut them down the middle, what dimension should be used so that the enclosed area will be a maximum, and what will the area be? Okay, we know that he has 120 feet of fencing for the max, so let's figure out the perimeter. We know that 120 is going to be equal to the distance around, so that's 4x plus the 3 y's that we need. And then we also are asked to maximize the area. So we need an expression for area. Well, it's going to be in terms of x and y. And of course, area is length times width. So what we need to do is figure out that the length is 2x and the width is y. Now, I'm working with x, y, and a here. So I need to take the expression for perimeter and solve it for y. Or x, but in this case I'm just going to solve it for y. Get everything in terms of x and then substitute it into the area expression. I'm then going to use the calculator or solve it algebraically. So we'll take, if you think about what this is going to look like visually, where a parabola has a maximum, it's going, well, that's a terrible picture, but it's going to be someplace up there. Pretend this is an actual parabola where it's symmetrical. There's my maximum. I can find that maximum either by finding the x coordinate for the axis of symmetry and plugging that in, or by using the calculator once I get an equation. So let's get started with that equation. The perimeter, I have to solve for in terms of one variable and then substitute it into the area, since I am looking at area as a function of the length, in this case, x. Okay, so if I solve this for y, I've got 3y is going to be equal to 120 minus 4x. Divide everybody by 3, and y is equal to 120 minus 4x over 3. Now, let's get the area in terms of x. I'm going to substitute my new expression for y in terms of x into the area equation. So that's 2x times 120 minus 4x over 3. What you get here is 240x minus 8x squared over 3. You can rewrite that in a couple of ways. Doesn't really matter how you write it. Fact is, you're looking at an expression for area in terms of x. Here it is. And then what we're going to do, type this into the calculator. We have to fiddle around with the window, and here's what we want if you're doing this on the calculator. A domain where the x's go from 0 to 60. The x min would be 0, the x max would be 60. And what I find when I get the window right is that I have a maximum at x equals 30. And so what I need to do then is plug 30 into one of my equations. 20 equals 4 times 30 minus 3y. Then I can solve for y. But that doesn't quite look right, does it? Because then y would have to be 0. Okay, pause for a second. What I want you to do is type this into your calculator, see what you get here, and we'll be back in a moment to talk more about this one. If you were going to solve it algebraically, you would take, you'd make this a, you could make the, rewrite this and make it say negative 8x squared over 3, let's see, plus 240 divided by 3, I think that would be 80x. And so if I use the quadratic, the part of the equation, to find the axis of symmetry, my b value is 80, so I'm going to take negative 80 over 2 times 8, and I am going to get negative 80 over 16, which I believe is 5, negative 5. Okay, we might have, oh, I'm sorry, and A is -8 because we need to have a positive answer here because X can't be a negative number. Okay, so now when we plug 5 in here, if X should be 5, then we can figure out what Y should be. So we could plug X in any number of places. Let's plug it in here to solve for what Y has to be. So we get 120 minus 4 times 5 divided by 3. We get 100 over 3. So we end up with Y value that should be 33 1/3. Okay, let me pause here to tell you that this is an example of the most complicated sort of problem that you would get. These are reach and aspire to level questions. The kind of question that I will be asking you about on the quiz is something like, let's see, I give you an equation, g of x, models the height of a coin tossed, from the top of a building, and it's negative 0.8 x squared plus 0.17 x plus like 150, right? And I would ask you where the coin reaches its maximum, how long it takes for the coin to hit the ground, etc. So we practiced a lot of these word problems previously, and the word problems that I have given you for homework are, in fact, much more challenging. Okay, we will do the second problem here with the open box modeling in the next video. So I'll see you there.